Hello. In this video, we're going to cover OSPF for Palo Alto Network's next generation firewall. So in this example in our lab, we have a VYOS router. It's our dynamic router that we're going to do our OSPF peering with. And we're going to use the Palo Alto Network's next generation firewall, so FW01 that we've been using throughout this video series. We're going to do this on Ethernet 1, so we're just going to peer across the one network. Okay, so we're in our VYOS router, and I want to show you this configuration real fast in case you decide that you want to set this up in your own lab. So we have our Ethernet 0, which is our connection to the internet, where we're going to peer with our firewall that I showed you in the diagram. So 10.249.1, and this is .5. And then I've created two dummy interfaces just to have some networks to redistribute into OSPF over to the firewall. So we have 10.64.10 and 10.64.20, both /24s. And then I've also created a loopback interface, 10.64.01. So if I scroll down here a little further, we have our protocol OSPF, and we're using area 0, but we're going to use the format of 0.0.0.0 as this is what's necessary in the Palo Alto firewall to configure the area, the quad method. So we're going to advertise our networks of 10.249.1.0/24, our loopback address. We're going to advertise our 10.64.10 and our 10.64.20 addresses. We've created a basic authentication for OSPF on interface Ethernet 0 using MD5. And then we have our router ID configured of 10.64.01. That's pretty much the end of our configuration necessary for OSPF. So now we're over here in our firewall, and I'm going to start out with on our interfaces under loopback. I'm going to create a loopback address of 172.23.10.1/32, and I'm creating this solely to be my router ID for OSPF. So you'll notice that I do not have a security zone. That is intentional here because I don't want to route traffic with this yet. I just want it to be my router ID. When we actually go through the configuration of some other routing protocols, specifically BGP, we'll probably use this loopback as an actual routing point. But for now, I just want to have a routing ID, and I like to have a physical interface to be that. So we're going to go ahead and create that. And then if I go back to my routers, so over here on the left-hand side under network and routing, we have our logical router. So we're using the advanced routing engine. We're not using the legacy routing engine, which has a virtual router. So one thing you'll notice right off the top that we have all of our routing protocols broke out under here outside of our logical router. So inside of our virtual routers, the individual routing protocols are a part of the routing protocol in the individual routers themselves. When we moved to the advanced routing engine, we broke all of this out so you can have shared profiles across different virtual or across different logical routers to be able to have more granular control over your routing protocols. So I'm going to go under routing profiles. So under our OSPF routing profiles, we have a few different ones. We have our global timers for like LSA minimum intervals, our initial delay, our hold time, our max hold time. We also have OSPF interface timer profiles. We have a default one that has our hello interval, our dead interval, our retransmit interval, and our transit delay interval. So if you need different settings for these because your other end is configured with different settings, you can create new profiles. We also have an OSPF interface authentication profile, and we have an OSPF redistribution profile. So when we looked at our VYOS router, we saw that we had an authentication. So here I'm going to go ahead and create a profile, and I'm just going to call this OSPF auth profile. And then I'm going to set the type to MD5 because ours was an MD5 hash that we're using. I'm going to add a new hash. I need to give it a key number, and then I need to actually put my key in here. And I have a pretty simple key. Then I'm going to use, and I'm going to confirm my key. And I'm going to say OK. So now I have my MD5 authentication profile hash. If we're doing bidirectional forwarding, there is a default profile where it has some minimal time. It shows that we are the active BFD router, so we'll control bidirectional forwarding. If you needed to create a new one, you could. So going back to our logical router, we're going to go into our default router, and we're going to go to the OSPF tab here on the left. We need to enable OSPF. We're going to set our router ID, the IP address of our loopback that we set. In this example, we're not going to do a bidirectional forwarding profile, which means essentially it's disabled. I'm going to set my general timers to default, so I have those here. And this is for OSPF-wide, since we're setting it here on the main tab. If I had a redistribution profile that I wanted to set up specifically for OSPF in general, I could set that here as well. So under our area, we're going to click Add, and we need to add a new area. So for this one, we're going to use Area 0, but we have to use the Quad 0 format. We have an authentication profile, but we're actually going to set that on the interface as opposed to for the area in general. And then we have a type of normal. So here, if you needed to change your OSPF type to a stubby area or a not so stubby area, you could set that here. If OSPF, this was an area border router, we could set up our route filtering for incoming and outbound routes. If we have on the range tab here, if we have any summary routes we need to configure, we would configure those here. On the interface tab, we're going to go ahead and add our interface. So the first interface we need to add is our Ethernet 1, which is our connection to the internet, where we're going to peer with our VYOS router. So link type is broadcast. It could be point to point. It could be point to multi-point. Since we have it configured as broadcast, the default setting on the VYOS, we're going to leave ours as broadcast here. If these settings don't match, they will not peer correctly. We're going to set this as a priority of 1. We don't have any timer profiles, but we do have an authentication profile since we need to authenticate. We were just going to inherit whatever BFD profile we have for OSPF. If we needed to set one specifically for this interface, we could. And then we have a cost of 10. So I'm also going to go ahead and add 2 additional networks to advertise my internal interface. And then I'm going to add my DMZ interface. So these networks will get advertised into OSPF. And then I'm going to say OK. And then now we have a fundamental OSPF configuration. So I'm going to click OK. And then I'm going to go ahead and commit. And when the commit is completed, we will jump back into the video. Okay, our commit's completed. So we're going to close this out. I'm going to refresh the page. And then I'm going to go and see if we have actually built a peer. So I'm going to go to more runtime statistics for the default router on the right-hand side. And then I can go to my OSPF. I can see a summary of the configuration we've made. I can see the area that we have configured that we're participating in. I can see my interfaces that are participating in OSPF. And then I go to my neighbor tab and I see 1064.01, which is the loopback address, the router ID of my VYOS router. I can see its neighbor address is 10.249.1.5 in area 0. But I see that we are in Xstart, so we're stuck in Exchange. So obviously there's something blocking the progress, the handshake between the firewall and the router. So I'm going to jump into my VYOS router. And from here, I'm going to do a show IP OSPF neighbor. And I can see that here I have the router ID 1023.10.1, the loopback we configured. I can see my peer address is 10.249.1.2. And I can see that I'm stuck in Exchange Start here. So I'm going to go back to the firewall. I'm going to close this out. And I want to go to the monitor tab to do a little troubleshooting here to see if we can figure out what's going on. So right out of the gate, I see that I have some drops from outside to outside from my source address of 10.249 1.5, which is the VYOS router, going to 10.249 1.2, which is the interface of my firewall with application OSPF, and it's denied by the interzone default rule. So because in the other videos, you will know that if I jump over here to policies, we only have a rule that allows ping specifically. We only have a rule that allows traffic to go from the inside out to the internet, and then everything else is denied. So I need to create a rule to specifically allow OSPF. So I'm going to click add down here at the bottom. In my rule, I'm going to allow OSPF. And then this is going to be a universal rule. This is going to be allow OSPF traffic to peer. And then I'm going to tag this as an outside rule. I'm also going to tag it as a routing rule. And then my group by tag, I'm going to group it by routing rules. And then for the source, I'm going to add a source of outside, and I'm going to add an address of my ISP1 subnet. So this subnet is the only subnet that we have participated in OSPF, so I'm just going to lock it down to devices on this subnet. Same thing for the destination. I'm going to add an outside zone, and I'm going to add my ISP1 subnet. The application, I'm going to lock this down to OSPF. And then for the service category, I'm going to leave it as the application default. For the action, I'm going to allow it, and I'm going to log at session end. I need to move this rule, or I'm going to move this rule above my internet rule here. And then I'm going to go ahead and perform a commit. And when this commit's completed, we'll jump back into the video and we'll go through our troubleshooting and see if we actually have a full exchange with our neighbor. Okay, our commit is completed, so we're going to close this out. We'll go back to our monitor tab, and it's refreshing itself, and we'll see if we get any allows here to go through. We'll give that a second. I'll go back to my policies. I'm going to scroll to the right. I see that I have some hits on my rule. So I know the rule is getting hit. So I'm going to jump over to back to my network, and I'm going to go to my runtime statistics of my router. I'm going to go to OSPF and the neighbor tab. And now I see that my VYOS router is in full, and I am the designated router. So if I jump back to my VYOS router and I do a show IP OSPF neighbor, I see that we are in full. The VYOS router is the backup router, so it is the BDR. So if I go here and I do a show IP OSPF route, I can now see 172.23.8.0 and 172.23.20.0. So from this router or networks here, I should be able to access the routes on the other side. And from the firewall, I should be able to see under my routing table, I see 10.64.0.1, my loopback, 10.64.10.0, and 10.64.20.0 in my routing table, and they're being propagated into my forwarding table. Under my routing table, I can see that I learned them through OSPF. I can see their metrics. I can see the interface they need to go to. So we actually have routes connecting. So what we're going to do is jump over to our virtual machine that we have, and we're going to see if we can access those other networks. So from our virtual machine real quick, we're going to try to ping. We're going to start with the 10.64.10.1 interface and see if we can access beyond the dynamic router to that dummy interface we created, which is simulating a network beyond our initial connection point into our OSPF network. So We can see that I can actually ping that network, and then I will see if I can ping 20.0. So I can. So we know that we are getting routes propagated to us, and we're able to route traffic from our inside network over to what would be a network connection inside of the dynamic router. So we have OSPF actually functioning properly. So I'm going to jump back to my firewall, and I'm going to give you an alternate method of distributing your routes. So when we built our routing out, we actually added under OSPF in our area, in our interfaces, we added these two routes as participating networks. So if you did not want to do this, there is a different way you could do it. So I'm going to go ahead and remove these two interfaces and say okay and okay. And then I'm going to go back to my OSPF routing profiles. And down here at the bottom, I'm going to add a redistribution profile. And I'm just going to name this OSPF connected. And in here, I'm going to redistribute my connected routes into OSPF. So you can set the different metric types. So this is by default set to a type 2. If you needed to filter out some of these different routes, you could as well. So for this, I'm just going to click OK. And now I have an OSPF connected routing profile. So if I go back to my logical router and I go into my default router and I go to OSPF and I click on my redistribution profile here, I can redistribute connected into OSPF. So I'm going to click OK. And then before I commit this real quick, I'm going to jump into my runtime statistics. So from my router, I see that the 10.249 is a connected route. 10.249.2 is a connected route. 172.23.8 is a connected route. My loopback is a connected route, and my DMZ interface is a connected route. So these are all the routes that are going to be populated into my OSPF for redistribution. So I'm going to close this. I'm going to go ahead and run a commit. And when this commit finishes, I'll jump back to the video. Okay, our commit's completed, so I'm going to close this out. I'm going to go back to my VYOS router. And I'm going to show you the difference. So before, when we did a show IP OSPF route, you see that under my OSPF network routing table, I can see from my firewall, I had 23.8 and 23.20. I didn't have the loopback because I didn't add it as an interface. So in this example, I'm going to click in here and show my routing table again. You'll notice now that under my network route, I don't have those routes here anymore. I have the loopback showing up as router routing table, and then external routing, I have all those same networks. So 23.8, 23.10, and 23.20. So all of the ones that showed as directly connected are now participating inside of OSPF. So that's the other way, is definitely the more efficient way to do it based on what we were trying to do. My only reason for really building this out is to show you how OSPF redistribution works and building those redistribution profiles. So if you had other routes that weren't necessarily attached to an interface, or that you just didn't want to add the interfaces to, you could actually redistribute them in via several different ways. We just chose connected to be able to do this. So just an example of some different ways that you can manipulate OSPF. This is a pretty fundamental configuration. There's a lot more you can do with OSPF. So I hope this video has been informative, and thank you very much.